In this video, we're going to be using the Aider AI coding assistant along with the Claude 3.5 Sonnet large language model to build this AI Retrieval-Augmented Generation app. That's right, we'll be using AI tools to build an AI app. This won't be a throwaway app either. It'll be an app that you'll find useful after you complete the tutorial. Now in this particular app, we're only using web pages for our content source, but you might like to also use PDF files or other content sources. So by the end of this tutorial, you'll also have the knowledge you need to extend the functionality of this app using an AI coding assistant if you'd like. Retrieval-Augmented Generation is also known as RAG, and just in case you're not familiar with RAG, it's a way that we can provide topic-specific knowledge to a large language model so it can help answer questions on topics it wasn't necessarily trained on. Also allows us to provide more up-to-date information to a large language model. This is how RAG works in a nutshell. First, we have to get our content, web pages in our case, into a format that lets our app fetch the parts of the content that are most relevant to our user's query. That means that we need to load the web page content, then we need to split that content into chunks, and then for each chunk we need to convert those into what are known as embeddings. Then we store those embeddings into a special database known as a vector store. Once the content is in our vector database, users can start asking questions. When a user asks a question, this is what happens. We go to our vector store and we use the question to find the most relevant chunks of data, relevant to the user's question that is. Then we combine the user's question with those relevant chunks of data. We feed that to the LLM as a prompt, and then we get our answer. Having said all this, I'm going to show you another method of learning new things like RAG on your own. After we use Aider to build our RAG app, we're then going to use another AI assistant called Cody to teach us about RAG and how we've implemented it in our app. AI is going to help us build something useful, then it's going to teach us about what it built. Talk about efficiency. For this tutorial, you'll need to have these installed. And you'll need two API keys, one for Anthropic, for the Claude model, and another for OpenAI, for the GPT-4 model. Aider will use the Anthropic APIs to generate our application. Then the RAG application that Aider generates will use the OpenAI APIs to answer users' questions. I'll put links to instructions for installing all of these tools and getting these API keys in the instructions below. I'll also include all the prompts you're going to see in this tutorial in the description. Now let's get started. Now before getting started, make sure you've installed all the tools listed in the description section below and that you created the API keys that are mentioned there. Then create an empty folder in VS Code as I've already done here. Then in VS Code, open a terminal and ensure Aider is available in your path. One easy way to do that is just to type aider-help. And you should see something similar to what you see here on my screen. Now we need to set an environment variable for the Anthropic API key, like this. Now this is the API key Aider is going to use to invoke the Claude 3.5 Sonnet LLM for generating our app. Of course, I'll revoke this API key before this video goes live. Now we want to start up Aider and we want it to use the Claude 3.5 Sonnet model. So we'll run this command, aider-sonnet. Now, since we haven't initialized our project using get, Aider asks if we'd like to do that, and so we say yes. Now Aider will automatically commit the changes it makes locally, providing detailed commit messages. All right, Aider's up and running, and it's waiting for our first command. We want to develop our RAG app in Python using a popular framework called LangChain. This page provides information on what RAG is, how it works, and provides various code snippets to show us how we implement RAG using the LangChain framework. This is a perfect information source to provide to Aider to allow it to generate source code for our LangChain RAG app. So, to provide contents of this web page to Aider, we go back to our Aider session, and we use this Aider command /web, and we pass it the URL of the page that we just looked at. Aider is now fetching the contents of this web page and storing it in its working context so it can use it to guide it in generating our RAG app later. Now that Aider has the information it needs, we'll have it start generating our RAG app. So in the Aider terminal, we'll enter this prompt. Use the LangChain RAG tutorial documentation, which I provided to you previously, to generate a simple RAG app in Python that uses the LangChain version 0.2 framework. The app will allow the user to provide the URL for a web page and ask questions related to the contents of the page. The user interface will be the command line for now. The app should use open AI models and APIs. Generate all the required files, functions, methods, imports, etc., but don't implement any functions yet. Instead, just insert comments. Also, generate the Python requirements.txt file. Only implement the features I've requested. Okay, Aider's generating the code and it's asking for permission to create the files. We'll say yes, and it's created all the files. So let's take a quick look at what Aider just generated for us. It's important to point out that throughout the tutorial, the code that Aider generates for you will very likely be different than the code it generates for me. This is because given the same input, LLM output is non-deterministic, meaning from execution to execution, the output can change. My hope is that the output that you get is close enough to the output I get that you'll be able to connect the dots. And based on the information Aider retrieved from the LangChain RAG webpage that we provided to it, it created various functions that will handle different aspects of our RAG app. Let's start with the main.py file. Since we told Aider not to provide the full app implementation yet, it provided skeleton code with function definitions and comments to describe what each function should do. The functions here follow the basic flow of a typical simple LangChain RAG app. Load content, split the content into chunks, load those chunks into a vector store, and create a retrieval chain. You may recall our discussion of the main RAG components from earlier, but if this doesn't make sense to you, don't worry. It'll become much clearer in a few minutes. Because after we build our RAG app, I'm going to show you a very neat way to have another AI tool explain exactly how all this is working. Okay, Aider has also created a file named utils.py. This Python file is going to perform the functions of prompting the user for input and also displaying the answer that's going to be returned from our LLM. There's also a requirements.txt file that defines all the external library dependencies our RAG app's going to need. Now back in the Aider terminal, we can see that Aider told us that we're going to need to set our open API key so the RAG app can call the GPT-4 LLM. And it shows us exactly what we need to do. It says, in the .env file that it generated, we need to update the open API key environment variable with our API key. So we'll open that file, it's put a placeholder in, and we'll paste. And don't worry, I'll revoke this API key before this video goes live. Okay, before we can run our app, we need to install all of our third-party library dependencies. Remember the requirements.txt file? This is what defines all of our dependencies. So I'm going to open another terminal. I always like to create a virtual environment when working with Python projects. So this is how we do that. Python -m venv venv. And now I activate my virtual environment. What this does is it allows me to isolate all of the dependencies for this particular application from the rest of my global Python dependencies on my machine. Now we're going to go ahead and use the requirements.txt file to make sure all of our dependencies get installed. Pip install -r requirements.txt. Now this is going to take a couple minutes, so I'll be back when this is complete. Okay, all our app's library dependencies are installed. Now let's start fleshing out the app's implementation. We'll first tackle fetching a web page. We'll go back over to the Aider terminal and we'll give it this prompt. Implement the loading of a web page. Let the user provide the URL to be loaded. Print the contents of the page to the console. Leave the rest of the code as is. Okay, let's check out the changes that Aider just made. Or open main.py. Okay, here we can see that Aider just implemented the load and process documents. So now we're loading web pages. And it also implemented the getting user input. So we can see that it's calling the get user input in the utils file, which is prompting the user for a URL. Well, let's test it out and see if we can actually load a web page. So back in the other terminal, we're going to run the app Python main. We should be prompted for a URL. Okay, please enter the URL of the web page. We're going to provide this URL. And we won't worry about what the contents of this web page is right now. We're going to return to this a little bit later. But as you can see, it loaded the contents and it's printed them out to the console. Also, the app will need to provide the relevant chunks of the web page to the LLM so the model can answer the user's questions. This requires that we split the web page contents into chunks, create what are called embeddings on each chunk, and then store the embeddings into a vector store. We'll ask Aider to implement this functionality now. So we'll go back over to the Aider terminal and we'll input this prompt. Generate the implementation for loading the web page contents into the vector store. Leave the rest of the code as is. Okay, we can see the updates in the main.py file. Create vector stores, creating embeddings, and then loading our documents into the Chroma vector store. So now Aider's implemented the code for splitting the text from the web page into chunks. The code is now also converting those text chunks into embeddings and storing those embeddings into the vector database. Let's run the app again just to make sure we didn't break anything. Back in the other terminal, we'll rerun the main.py file. And we'll provide the same URL we provided before. And there's nothing much to see here except for this message that says, hey, we created the vector store successfully. So I think we're good. Nothing's broken. So by now we're fetching the web content and storing it in our vector DB, but we're still not interacting with the LLM for Q&A. For that, we'll need what's known as a retrieval chain. The job of the retrieval chain is to search the vector database, find the chunks of text most similar to the user's query, and feed these text chunks to the LLM along with the user's query. And of course, return the LLM's response. So let's go ahead and have Aider implement this retrieval chain for us. Over in the Aider terminal, we'll prompt it like this. Implement the code required to complete the retrieval chain and allow the user to ask questions based on the web page content that's been stored in the vector database. Use GPT-4o as the chat LLM. Okay, and these are the main changes that Aider just made. It's creating the RAG chain or the retrieval chain. Let's take a look at the chat prompt that Aider generated for us. Answer the following question based only on the provided context and will pass in the context at runtime along with the user's question or the input. This prompt formatting tells the LLM to restrict any answers to the contents of the web page we fetched. To be more accurate, to the most relevant parts of the page contents, which we retrieve from our vector database when the user asks a new question. If the RAG app didn't prompt the LLM in this way, the LLM would use data it was originally trained on to attempt to answer the user's questions. And this is not what we want in this case. The user might ask questions that require either knowledge that the LLM wasn't trained on or that require more up-to-date knowledge. Because of this, we have to provide that information to the LLM along with the user's questions. This is referred to as in-context learning. So let's check out the web page that we're using as context for our RAG app right now. This is a blog post by a developer of another AI coding assistant called Continue. There's a section on fine-tuning the LLM used by Continue Coding Assistant. Fine-tune StarCoder 2. The LLM it uses is known as StarCoder, and we're going to ask something about how we should perform this fine-tuning based on the contents of this web page. So, back in our terminal, let's go ahead and run our app again. Now that we have it fully implemented, we'll provide the context again. And now it's asking us, hey, what do you want to know about this? Ask a question about the web page. So we're going to ask this. Briefly summarize how I can fine-tune StarCoder with my own development data when using the Continue Coding Assistant. Format the output as Markdown. Okay. So it answers 1, 2, 3, 4, 5 bullets. Generate development data, extract useful data, fine-tune the model, push the model, and measure. And it seems to be in alignment with what I've read on this web page. So I think we're looking good so far. Hey, but who wants to run from the command line if you can run from a web UI? So let's go ahead and fix that first. We'll go ahead and quit our RAG app. Back over in the Aider terminal, let's give Aider this prompt. Add a simple Streamlit UI. Streamlit is a Python library for developing user interfaces. Add a simple Streamlit UI for this app that allows the user to do the same things they can currently do from the command line, but in a web browser. Also, give me instructions for running the Streamlit UI. Okay, so it's generated the artifacts and it's asking for permission to create a new file, streamlit app.py. We go ahead and say, do that for us. Also, notice that it's given us instructions for running the pip install requirements.txt again because it added the Streamlit dependency, and also how to run the Streamlit app. So let's go ahead and update our dependencies. We'll copy this back in our other terminal. Pip install requirements -r requirements.txt. It'll install the Streamlit dependencies. I'll be back when it's finished. Okay, the dependencies are installed for Streamlit. Now let's go ahead and launch the new Streamlit UI by copying and pasting this command from Aider back into the same terminal where we installed our dependencies. Streamlit run streamlit_app.py. And as we can see, we have a new user interface. So let's try the exact same thing we were doing from the command line. We'll provide the same URL to the same blog post. Now it's actually fetching the content and storing it into the vector store. We'll ask the same question that we asked before, which is briefly summarize how I can fine-tune StarCoder. Okay, it's passing the content and our question to GPT-4o and generating our answer. Okay, so there we go. And this looks very good. Looks like what we got before. So now we have a web UI for our RAG app. Okay, how about we see if we can get just a little more color out of our RAG app. So back over in Aider, we'll say add more color to the UI. I want to see some blues and purples with a splash of red. I'm not really good with colors, but it's beside the point. So let's see what we get. Okay, Aider's explaining the changes it's making, adding a gradient background, using blues and purple, style the buttons with purple, etc., etc. It made the changes. Okay, so let's go and check this out. And it did make some changes. Whether you believe it's more colorful or not, beauty's in the eye of the beholder, right? So let's copy the link again just to make sure we didn't break anything. We'll ask the same question again, asking about fine-tuning using StarCoder. Oh, it's added some little icons here. That's kind of cool. All right, there we go. Yeah, it added some more color. All right, so that's pretty cool. Still, we haven't touched a single line of code, have we? One last thing. You might recall at the beginning and then at least once or twice during the tutorial, I said we'd not only use AI tools to generate an AI app, but we'd also then use AI tools to teach us about the app the AI tool created. So first step in this, we're going to ask Aider to create a README file that explains the app. Back in Aider, we're going to prompt Aider like this: generate a README file in Markdown format for this project. Explain what the app does, the main technologies and components, and how to run and use the app. Okay, Aider's generated our README file. Let's open it up and take a look. Web page question answering app. This application allows users to ask questions about the content of a web page using advanced natural language processing techniques, combines web scraping, talks about the features, AI powered using GPT-4, command line interface, and a web-based UI using Streamlit. All the technologies that are involved, tells us how to install the requirements and run it and set our open API key and yada, yada, yada. Also tells us about our different files in our project and what each one of those do. Pretty cool, 2 seconds. That's awesome. We now have documentation that explains the app and how to use it. But what if we have more questions about the app, like how LangChain works and how we're using it in the app and how the various RAG components interact and on and on? Let's launch another AI coding assistant known as Cody AI. Now, if you don't have it installed or you don't want to install it, that's okay. This is mostly for demonstration purposes, and I'll do future tutorials on Cody AI. But it's another coding assistant that integrates with VS Code. So I'm going to select Cody in VS Code. I'm going to start a new chat in Cody. And what I'm going to do is I'm going to kind of focus Cody on a particular set of files I want to ask questions about. Now, it does see the entire context of our project. However, I find that it performs much better if I can focus it on the parts of the project that I care about. So I'll type @, and it gives me all the options for the files that I can put in our context. And I select main.py and utils.py. And I'm going to ask it this question. I'm new to LangChain and RAG. I've also never seen this code before. Explain this code, what it's doing, and the major components and their roles. When explaining the code and components, be sure to restrict your answers to the files and code that exist within this code base. So we don't want it hallucinating and making up stuff based on its training data. So as you can see here, Cody's generating an explanation. So it explains what's going on in the main.py file, the functions, the components that it's using to do its job, explains each one of the functions. And it also then starts to explain the utils.py file, its functions, what it's doing. And then it kind of gives us an overview of how the main function is orchestrating the entire process. Now, how about a little bit higher level explanation of what RAG is and how this is all working? Can you explain to me in simple terms the basic flow of this app? I want to understand the RAG process better. Okay, so it's explaining what's going on. It talks about the user input, web page processing, creating the searchable vector database, the question answering loop, and so forth. So it walks through each part of the RAG process. And then in the end, it explains again what RAG is and how it works. And of course, you can continue to probe and learn about the app from here based on what you want to understand better and what your needs are and where you are with your learning process. Now, I know that was a lot in a short amount of time. We started with an empty folder, an AI coding assistant, and a prompt that described an app we wanted to create. Then the coding assistant, Aider in this case, used that prompt to generate an entire working RAG app for us. Then we decided we weren't satisfied with a simple command line interface. No, we demanded a web UI, and Aider complied. Lastly, we used Aider and Cody AI to help solidify our understanding of RAG and LangChain, even generating documentation for us. If you'd like to see more videos on this or similar topics, please let me know in the comments below. And if you enjoyed this video, please do like and subscribe. I'm Tim Kitchens, coding the future with you, and I look forward to seeing you in future videos.